Here, let's try. Yeah, okay, this is Coffee Compiler Club. Here we go. Anything to do with compilers, language runtimes, garbage collection, typing systems, null or not the null, whatever. We argue these things all the time. It's all fair game. I reserve the right to moderate. Never had to do it. You are being recorded. This goes up on Twitter. I'm going to cut short the amount of effort I do for putting that damn summary together. That's what takes so long. I replay a 2-hour video to write a summary, and it's like not worth it. So hopefully it'll come up faster, the video.
Yeah, we can start the Google Docs.
Yeah, and Google Docs is up. I sent out a link.
Can you throw it again because the chat is empty?
No, I sent it out in email. I will send it out in the chat also, cool. But it went out in email.
I miss it. Sorry.
It's all right. And so I'll throw out my 2 bits of AA summary. The typing system's been stable. I got this guy, Marco Savetto, in New Zealand, who's been writing piano arithmetic in the typing system to prove that it's like sound or complete or insane or something. It's funny to watch. But the last couple bugs that come around were actually not bugs, were just prototype had poor error messages. And some debate about the minimal types. When your types get complicated enough, what is the minimal type that you would expect? So I claim the typing system is currently stable. I'm doing a whole lot of tech debt elimination in the AA code base right now. My main typing hack that was big and ugly, the main source of ugliness, was doing recursive types, cyclic and recursive types. And now I want to have fields be unordered so that, you know, structs with an X and a Y can be fed into a distance calculator that takes an X and a Y, but the X and Y don't have to be in the same order in the struct. And that means you don't do field comparisons based on where they're defined, but by their name. And that impacts pretty much every piece of code involving structures. So there's a giant tech debt thing going on there. And that was my 30-second summary.
Okay.
So
what was the problem?
Sorry, go ahead.
Okay, go ahead.
No, I was just picking a fight to get something started. I was going to ask Charlie why he's here. You're the irregular once in a while guy.
Yeah.
Was trying to be more regular, and then we had twins about 2 months ago. So
congratulations.
Thank you.
Congratulations.
A little less regular, and I guess I'd started a new job in March too, so that also took away some time. So yeah, everything's basically changed. But
and so if you hit the the nadir of sleep deprivation, it comes.
I think so. Pretty much, like, I don't know, a few hours here and there. If I make complete nonsensical comments, just ignore me, because that just means I'm not really knowing what I'm saying, but it's all good. I don't know, kind of out of the loop on everything these days because I'm not doing any VM work. So this is my chance to hear what other people are still doing and go on from there, because I'm just doing Java instrumentation now at Datadog. So different world completely. So this is my keep my fingers wet in compilers and GC.
Gotcha. You're here to lurk.
Yeah.
And maybe to nap while your kids are asleep. Here, honey, watch the kids for a second so I can do Coffee Compiler Club. I get it, been there, done that. Yep. All good. All right.
What was the piano number representation problem? What was he trying to do?
I mean, the test cases are kind of wild looking. Let's see here. I put it on cut down test cases. You don't want to see the cut down ones. See, the full cases are more. Here's a. Let me clean it up in Emacs before I throw a version in. This one is just Boolean algebra, no pianos yet. 10 seconds in Emacs. Okay, 30 seconds in Emacs. us, arguing over style and AA here.
That's how it starts. 10 seconds, 30 seconds, 10 years. Then you can't use anything else.
I'll be ready for dinner. Just a second, honey. I gotta finish this bug. Oh, somebody's trying to put timestamps in. Oh, that would be very helpful. Okay, so here is.
We have to agree on the timestamps because here it's circle clock.
We never found a way to format as code, but we could get to fonts that were fixed size, right? I can figure out paragraph styles, normal, title, sub, option, none of the above, text, size. There's no fixed size font. There surely is. Somebody tell me how to find fixed size fonts, because I've done this before. Arial, here it is. I found it. Google, you need to fix your docs to be like reasonable. So not color coded. Void is an empty struct. This is a Google Docs here. True as a struct that has an and, an or, and not, and a then else. False, a struct has and, an or, and not, then else. Then I merge them together and make a thing that I can pick out the true and the false after they've been blended. So now do this with a successor and a 0 and a couple other things, and ask the type system to like type it. He found a few bugs earlier on. Kind of got stable now. So none of the bugs are deep, but he had a lot more code going on than I had in there in a long time. So. But
what was the piano specific representation?
Well, that's okay. So it's successor and 0 as structs with functions. I say piano, and maybe I'm not using the right terms, but I think that's the right term. Like if you go drag it up here, he's got it on a GitHub page.
Piano is basically a representation with the 0 and the successor to represent any
right.
Number.
Marco, here's the horrific. See, people might be excited about this version of things here too. Here's like the argument over size. I'll throw into the chat, but then I'll because here's one of the answers. It's font's too big, the pages get wider. Buried down in here is like wide printed types, which I've carefully aligned. Let me go find a piano math though. It was not hard to look at. Here, Marco.
One question, Cliff, because last time you pasted this, I thought it was just a typo, but I see it again. The not of true returns true. Is that just a typo in the code you've pasted here?
Let me pull up Google Docs, one thing at a time. Which one's going here? Where are you seeing not of true? Highlight it in the Google Docs. Oh, no, that's correct. So that is not is a function which takes an unused, which is an argument that is thrown away, and returns a true. Well, true is just a variable name. What's the variable? Well, it's the structure itself.
Shouldn't it return false though?
Oh yeah. Oh, I'm sorry. Yes. Yes, this is separately. Okay, so break out bugs in his representation of Boolean algebra from bugs in the typing system. So one of the definitions he was using used nested types where you did let true equals struct blah blah blah, let true equals, let false equals struct with the false side embedded inside the true side.
And so it's correct in the false
structs to get true and false. And the other one was he put true and false as a top level members of an all struct, and they mutually referred to each other. And you get two different types out. Then he had a bug in the not, and that led to a funny type that came out. And the question was that type legit? And why did you get this type? And it was busted. And it took me a while to sort out that he had a not and a true. And that's just part of, what he was throwing in. And he kept the test case around. The test case was, exciting for finding bugs in the system, exciting for finding strangenesses in the types. So here's the nested encoding version. Let me here's a piano version. Here is a better one. Oh yeah, here we go. Let me throw this into the docs again. Yeah, 1 + 1 + 1. Yes, exactly. Okay, so here is, this is a really poor way the docs to take this. Let me go clean this up. Wow, if I can. Why? Oh, Google, what the hell are you doing? What's this little drop down?
It thinks you just added somebody.
think he's trying to do a
You put an @ so it assumes you are trying to summon someone to the dock.
oh God, how do I not do that?
Maybe you could paste the link to the doc instead of.
Yeah, I'll do the link. The issue, of course, is that there's 27 test cases here.
You can try, if you copy paste it, you can try it with Control Shift and V to unformat it.
So I was trying to pull out just the one test case. Let me delete what got pasted because it's pretty ugly. And let me see if I can turn into an offset. You want lines 257 to 288. It's a little easier. 257, but all of the test cases have some amount of excitement to them. And you know, the real goal here was to stress test things some more. So here's a version. So line 257, 288, you can see it says all is a, well, what is all? All is, turns out to be a struct defined at the bottom, which just has true, false, 0, and successor. And it has, you know, a bunch of things in there. So void is, again, the empty tuple. Error is a self-referential function that can't be called anyways except itself. True is an and or, then else. False, same kind of deal, except that the and the or use all.true or all.false to pick out the self-recursive true and false definitions. And then you know, 0 and successor are mostly kind of obvious, other than you have to like sort your head through what the hell he's doing. So I claim I get a legit type for this thing, which, as far as I'm concerned, put me well down the path of this is freaking insane and doing something sensible. So good enough for government work.
Yeah. The piano types, if you represent the arithmetics as a type, the types become huge, and you stress how does the type system and the compiler handle such big types. And
right. So the case and example there, 257 to 287, he's complaining that the type he gets out from line 290 to line 320, so you know, there's 30 lines of typing there, has line 304. E is a type which is cannot unify a function of empty to A and a struct of complicated whatever. And it turns out that it's correctly an error because he has a bug in his arithmetic, because self is a structure and self is being passed into, I forget where I found it. It gets passed to or 0, gets passed to then else, which gets passed to like true, then else, and then he and it's the then part. He calls then of with an argument void on self, which is a struct. So he's in fact trying to have a struct unify with a function, trying to apply a struct in a function application site, and the error message is correct, although you can't see it from. So you just argue the error message sucks, but this is the prototype. The error message is not intended to be, you know, fancy. So it took me, you know, an hour of screwing around to decide, hey, wait a second, you actually are doing this. And there's another hour to clean up the report and the types involved such that I could point out to him clearly and succinctly, this is where you had a bug in your definition, which is fine. So now we've been going back and forth for the past couple of weeks. It's been kind of fun. And like I said, it seems to have stabilized out. We're down to your error message style sucks here, but your program sucks, so you know, neener. We got one more person floating in. So yeah, that's what I've been doing with my summer vacation.
Cool. So besides this, does he's been able to encode more complicated structure, something?
Well, this is the guy that did the arithmetic, or did the typing system for Pony.
Okay.
Which influenced a lot of other typing systems floating around. So he's hoping I'll come back to him when it's time to do concurrency things in AA and argue what those types look like and why, which I'm happy to go do. So it's 11:17, yes.
I skimmed through the paper Aaron showed last time. It's go ahead.
You're not inaudible, Alan.
Oh, I said I was trying to get my watch in there so I could sync up the timestamps later, because
we are in different time zones, so we have to base it either on the Cliff's 10 a.m. when they started, because it's easier for him, because we are in different time zones.
Or offsets from the start of the clock.
Yeah.
Do that too, because that's what I'm going to play the video back. I'll sort on the video at the timestamp.
Yeah.
Okay. Either way.
Okay.
I don't care.
We'll get it. We'll get it eventually.
Let's say we're over optimizing here. It's too many compiler heads in one room.
Yeah. So I skimmed through this paper. Is basically about concurrency. It's basically an actor-based concurrency about the pony system, as I skimmed through, and it's impressive. It does a lot of things I believe are right, in my opinion. So when it comes to concurrency, it will be interesting to see how AA will interpret it, most of the stuff.
Yeah, hang on. I'm looking for. Here's the top level pony.
Do you think having a distinction in the types between this is a pointer that is unique versus this is a pointer that is local versus this is a pointer that's shared between multiple threads of execution is something that could be added in user space in AA, or something that has to be built into the language?
Yeah, so floating around back of my head is the thought that I ought to be able to, and I want to, have user space extensible types that are going to do this kind of thing. So I write these complicated structures in AA and in every compiler programming thing that got beyond a certain size, where I would love to have compiler support for sort of non-standard typing games, like this function call chain never blocks, where a blocking primitive has a particular tag on it, and anyone who calls a blocking primitive, however indirectly, has to carry the tag along in some convenient way, so that I can know whether I'm about to make a blocking call or not, because I'm doing reactive coding. Because my fucking GC is C++ implementation of hotspot, and if you take a GC cycle, this pointer moves, which only happens if you've blocked, and whatever. There's a lot of use cases that I keep running into. So I want an extensible type system that would be able to do what Pony's trying to do. I don't know if I can get there, but I have a lot of flavors of things like that I would like to be able to represent, and having it stuck behind a compiler wall makes it much harder for other people to do something useful. So like metric versus English, physical unit math is another one you'd like to see extensible at user level, without doing what Marco's doing with piano math, where you had a struct for everything and everything a struct, and you typed like, okay, it works, but oh my God, that's not what you're looking for. You want some sort of like simple annotations that have within them some sort of lattice-like thing going on. I don't know what the right nomenclature here is. And then the compiler happily infers where you don't need annotations and lets you throw down annotations where it can't, or whatever. Session types, there's somebody doing, yeah, right. And there's like security related versions where you would like to know some version of the pointer to my key didn't escape or didn't cross paths with something else. Bare strings don't get handed unfiltered to SQL queries and shit like that. So there's a place. Can I do it? I don't know. Would I like to do it? Yes. Do I think it's possible? Right now I do, but I don't know until the proof of the pudding's in the eating, So very much yes. Oh, Rust, that's the other big one. Doing just local allocation games or memory lifetime management games, where I'm hoping I can get away with a lot fewer annotations than Rust does. The borrow checker type infers happily for you.
Do you envision a borrow checker implemented in the compiler to track that
Yeah, that's what I'm saying.
Like
I would love to have something that behaved like a borrow checker or that did mostly for you. And could be, it would decide you had to GC or ref count a thing and it just fixed it for you behind your back and you didn't care, or you cared a lot, in which case you asked for help and then the compiler told you, no, you're about to leak this thing. What you want to do about it? Right.
Something I've been experimenting with is because I just am really lazy and don't feel like and I just didn't want to implement. I was like, I wonder if I can just see if I can let userspace just like, oh, they want to create a compiler plugin to do that tracking for you. So that way I just provide the users the ability to do that. And then I don't have to. And if it becomes good enough, then maybe I can talk to them about stealing it.
Yeah.
But then again,
mindset.
Yeah. Then again, I might be the only target for my crappy language. So
I don't know. See where it goes, right?
Yeah.
What's there's like half the people in this call are doing their own language.
Yeah.
So it's all good.
Yeah, just been fighting the LLVM API. I'm trying to figure out how exactly it works because documentation is a word.
I'm happy to not fight the LLVM API and never touch LLVM.
I don't feel like learning X86 again right now.
I've done it so many times. I'm just going to do it. There's like a stupid pet trick you do where you write your high-level assembler in your favorite language, AA or C++ or Java. You write your high-level assembler. Now you have a simple 3-address risk that you go code to. 2.5 address risk you code to.
I was thinking about actually writing a macro assembler in Java just because, I don't want to do it in C++.
Oh yeah, do it in Java. Yeah, fine.
Yeah, because I was like, because I was originally doing the implementation in C++ and hating myself. I'm like, why am I doing this? I can write it in Java way faster.
Right. Now, no, backport it to C if you need it in C, but port it. Don't write it in C and debug it and all that shit. I did that once before. Did it again at Azul. Did it again for however many freaking ports I did for a hotspot. There was an Itanium port I did a Spark port I did. I want to say when an ARM is an X86 of 2 versions. So I'm only up to like 5. I know there was a 6th. There were 2 Spark versions, 2 X86 versions. An ARM and Itanium, but there was another chip that was funny. Never mind.
So do you just put off intrinsics until there's a specific use case for that intrinsic, or?
Right now I am, yeah.
Because I can imagine just going through and adding all the count population type things in just some CPU library.
Yeah, pop count and crap like that. Yes, that one goes off in a funny, like math.popcount or whatever. Pop count, it can be efficiently done, and there's occasionally uses for high efficiency, high throughput versions. So you want it as an intrinsic somewhere. It goes someplace like math.popcount. Same for square root, sine, and cosine, for which X86 has magic special acceleration support, and you want them to show up in the intrinsic. Fine. CAS is the one guy I'm tempted to throw in the language proper, because it modifies an L value, which requires some amount of parser support. Or you do like you do in Java, where you have to take the address of something, which now you need an atomic field updater. What's an atomic field updater? Well, it's the L value of a field. So Java doesn't have the L values, so you can't write it in the language without jumping through hoops. And one of the first things I do whenever I do any of these concurrent algorithms is I write all the little accessors for getting at CAS and the pieces that need to be CAS, and I have a bunch of boilerplate at the top of non-blocking hash map and the long variant and the bit-wise variant and one of the set variants, and I don't know, the queuing guy, and there's like 4 or 5 others, or a bunch, where they all start with this boilerplate at the top. Import unsafe, build atomic updaters for the following fields and the array references and whatever other crap you have to do. And then you can go write code where you make a call that looks kind of reasonable for a CAS, but you include in the call all the things to build an L value, the base address and the offset. Sucks. So that one's probably in the language directly. Every modern hardware has support for such a thing, since they all do some sort of atomic update. They expect multi-threading, and everything else probably goes in a library somewhere. All these things.
So Anton, what was about you want a borrow checker implemented so with some kind of API, so you can just throw it in your compiler to implement the API and you have a borrow checker for free or something like that.
Okay. Sorry, I was reading Aaron's comment about things. It's fine. Say again. What are you asking?
I asked Anthony about the borrow checker. If I understand it correctly, you want a compiler plugins with some kind of API, so you can throw it in your compiler and implement your API and get the functionality until you need it. Is that something?
Yeah, I'm looking into that now. It's right now. It's just I'm on the third implementation of the compiler, so it's a matter. Once you give everybody the AST information, things are relatively trivial. Depending on providing it to the plugin. I'm not sure about the borrow checker, but I am just not interested in writing a borrow checker. The only thing I right now do is immutability access rules, because I really like things being immutable by default, like in Rust, how it's just like you have to request immutability. So it's the only thing I have in there right now.
I'm leery of handing out compiler IR because you're gonna get locked in your IR, but fine.
Well, it's my stance on it is this is an unstable API. It can change anytime. Do what you will, but if I can improve the compiler, then I'm going to improve the compiler.
Standard wiggle words, right?
Yeah.
Okay. Yeah. Pick your poison.
Yeah.
And I don't use an AST, so I don't know. I use the sea of nodes. Entirely different.
I was looking into the sea of nodes and then I read AA and I'm like, I will do this later. Different style than I am used to, and I have to sit down and grok it for a bit.
Yeah.
Oh no, it's really interesting. I actually really, because I read your I think it was your thesis on sea of nodes. I'm like, okay, this is interesting. I'll try this in one of my when I am not halfway through an implementation.
Yeah. Yeah, it's easier to do it from the start because you start doing all the little weird things up front, and then you realize they're all, like, what the hell is this and that? And then once it gels, it kind of flows together and everything else comes out of it pretty easy. AA is a big old mess because I've had train wrecks of various typing systems over 2.5 years.
Yeah.
So there's a lot of train wrecks in AA right now, which are leftovers from I tried this and I failed out on this and that. And there's elimination is going on this last couple of weeks.
There's a fun thing going on called Lang Jam. I have to find the thing on GitHub again, where people, where either people are like, oh, you have 2 days to create like a tiny little language. Let's see if I can find that,
including a parser, I assume.
Like including the parser and all that stuff. Yeah. Here it is. Not sure. But I was thinking, because I have a SO lang that I spec'd out with my friend. Well, I spec'd out for my friends because I went on a rant about how I hate significant white space based parsing in languages.
I do too, but fine.
And
it's a different one.
Yeah. And it's just like I just wanted to hurt them because they told me I was wrong. So I'm like, well, let's take it to its logical extreme.
I'm actually kind of disappointed because a lot of the internet material, it's let's build a compiler and you basically build a lexer and a parser and your trees basically doesn't do it. It doesn't have a type system. Then trees are basically useless without their types. I guess it still qualifies as a compiler, but don't call it a compiler. Call it a toy or prototype or something.
Yeah. I ran into that issue because I got the lexer and parser done. I'm like, well, that was easy. Like the parsing's not hard. It's, oh, I have to get the type system working. Oh, well, there's that first bullet in my foot.
Oh,
yeah.
Now I need to generate code. Oh, okay. Well, that's also really fun. Time to learn X86 or use LLVM, or just compile to Java bytecode using Polyglot. Draw is amazing.
I would claim that the order of ease of use here is generate bytecodes, generate X86, call LLVM.
Yeah, and then Yeah, I was like, well, there's another bullet hole in my foot right there because I've learned LLVM now. And it's like, well, you know, what sunken cost fallacy, let's go full bore now. And you know, it's
Yep.
but you know, it's working out. Though I'm just trying to figure out how I'm gonna link things. So I have to call into C, which is a whole nother can of worms, but whatever.
FFI, the FFI, yeah.
It's I know the convention that I want. It's just a matter of sitting down and getting it implemented. And it's not important enough right now to where I care enough. But it's just like, okay, well, do I do that or do I just implement a syscall library and just manually do the syscall? Well, let's do libc for right now because I don't feel like doing syscalls for 3 different operating systems and implementing that for 3 different operating systems. Yeah, it's like, yeah, link against libc and I'll figure out the rest later. Just get something working and then iterate into it. I like it more. That's not perfection solves nothing and you'll never finish.
Exactly.
Do you have a use case in mind in your language attempting to go more deeply without
without
general
libc?
part? No, I'm asking what do you envision from the language? Do you have some kind of use case or purpose you're creating?
It's mainly for my style of programming. I wrote it because I was just tired of dealing with C++ for some things. And I was like, well, you know, okay, I want structs that are actually structs, not classes. I want like pure data. I do not like the idea that my data holder structures can all suddenly have accessors and setters for and constructors for no goddamn reason, aside from it's a V table. So obviously we need to have a class, which is also a V table, but with private scoping rules. I like some of the stuff that Go does with its multi-return values. So I just pulled that into the language. I also like Go's concurrency model. So I'm trying to figure out how to implement that into a language that sort of compiles them.
You looked at Swift?
I have looked at Swift, but last time I looked at Swift, it didn't exactly compile on Linux too well. But that was several years ago.
Yeah, right. Well, I know I've been excited and work on it for a long time, but I don't know if they've gone. Yeah, I don't know if they're off the.
But something I really wanted from the language, actually more from the tool chain, and it made me realize I probably got to write the assembler and the linker and all that stuff myself, is I want Go's ability to compile. Go, the reason why I program in Go is not because I like the syntax. I really don't like Go syntax, but has one of the best tool chains for cross-platform development that doesn't have that's not the JVM. That actually compiles to native binary that you can do from any language, any system, and it just compiles to any system. Like there is no language that I've seen that's able to replicate Go's toolchain. And
Zig, I don't claim they're replicating it, but they do cross. Well, I'll put a link in the chat. They do cross-platform compilation as a standard default thing.
It's just
the language is also a little odd.
Yeah,
fine.
If I remember right, they claimed that they were a better C compiler than C's compilers.
Yeah, they have a bunch of things.
They have a compiler.
But they have a compiler, and they do cross-platform compilation as their everyday normal default.
Yeah.
So targeting, ARM code from your X86 desktop or whatever.
It's just I feel like that if you remove the cross-platform barriers, you open up just another way of programming that doesn't involve downloading 3 versions of GCC. And GCC is another
cross-platform compiling between?
I do have ARM, X86, and what's the other one that's really weird that they're making me compile for because I do stupid things. MIPS.
The what?
MIPS.
The MIPS? The RISC-V thing or MIPS?
MIPS.
I haven't heard MIPS come around in like 20 years. What are you doing?
Yeah. It's because MIPS is part of like an old video game console, so they needed somebody to do.
So you're writing video game consoles, emulators, or you're actually running on it. Then you're writing MIPS code. You're running on it.
Well, what's funny is I started writing the language was because I was writing an emulator I was trying to write. I still am writing an accurate emulator for the NES for tassing. And I've toyed around with toy languages, and by the time I was dealing with templates in C++, I was wondering what I was doing with my life.
Well, that's where you shoot yourself in the head, not the foot.
Yeah. So I'm like, well, let's do something else that's equally as stupid. Let's write a language that I will actually enjoy writing the simulator in. And, you know, and it's been about 2 years, and I am actually still enjoying it. So,
okay,
you know.
Well, there you go. That's all good.
Yeah.
Like I said, I've been AA like 2.5 years or something. It's been a while, and I'm enjoying myself. I'm having a good time, learning all kinds of shit about typing theory.
But
yeah, I believe much nicer things come out if you're doing it because you want to, and not you want to build a product to fund some company to fund yourself, and yada yada yada. It will come out much better.
Well, that's the biggest lie that people believe is like, oh, if I build this, then, you know, I'll be able to make a lot of money out of it. It's like, no, make it for yourself first, and then maybe you'll be able to make money out of it.
And maybe you just made it for yourself as well.
Yeah.
Right.
Yeah. Or you are starting with a specific problem in mind to solve it. And you check the math that a bunch of people want your problem solved, and off you go.
Right. Yeah.
Or a small number of people with a bunch of money.
Yeah.
That works too, actually.
And that worked for the Wolfram guys, so you know.
Yeah. And
but the creator of Wolfram is a super smart guy. Don't underestimate it.
Oh no, I agree.
No. Okay.
Yeah, no,
I'm a long time startup guy. I did a bunch of pivots at different companies, different times.
Yeah.
You got to go where the money is if you're doing that game, which is not necessarily what you were, hoping to do or wanting to do or started in on. You got to follow.
Another fun reason, and this is just really weird, because another reason why I started the language was because at the same time I was doing the emulator I was working on SOLang that abused Unicode to the nth degree. I was parsing Unicode in C, and I'm just not having a fun time because I don't like doing that ever. I'm like, well, why did I do this in Go? And it has a rune type. Well, let's add the rune type to my language.
What'd you call it, a rune type?
Yeah, it basically takes a Unicode or a glyph from a language and just converts that to the Unicode and Go. It's the very dumb way I'm saying that, but imagine a char but for a Unicode type.
Right.
That's basically what it is.
Okay. I've fought so many Unicode disasters over the last 10 years that I'm just like, I'm either looking at a pile of bytes and I want to do pattern matching, string-like pattern matching on a pile of bytes. Don't fucking talk Unicode to me, or I'm going to be slow. And you can have it either way you want, but you can't have fast and doing something sensible with the damn thing as a Unicode.
Most things I do, I just read it into memories, and I'm willing to eat that slow cost for the eat into memory. I'm like, okay, now I can start doing the optimizations.
Yeah, I tried doing giant log file parsing and Unicode in your face.
Yeah.
Didn't work. I had to go turn that off. Fine. Old stuff.
I hate.
Okay, last time we did the IDE. Now I want to do the build and build two and build chains game. No arguments.
What do you mean, no argument?
Say what do you want from a build two? No. So what do you want from a build two?
This is only ever arguments. This is like everyone laughs over Emacs versus VI because, of course, graphical IDEs won the day. So who cares? Except that they didn't, but it's close.
Okay.
But build tools, holy shit. Okay, I have to do because you want the rant, so you get the rant. So I have only ever that's fair. Okay, I have tried Gradle at a couple of projects. It sucks hugely. It is technically incorrect. It is morally incorrect. I can step you through both of those. It was more time burned, and also you had to have a full-time Gradle build engineer for a modest project. It was just, I'll never, ever, ever let Gradle touch any of my projects ever again. I took some bunch of engineers, senior guys, like best advice. They said, "No, Gradle's great." No, more time wasted on Gradle than anything else on the planet. After that, the things that I want out of the build system, the only source of correct atomic update of build artifacts is the file system, which will give you an atomic update that you've replaced a .o with a new version of .o, or the .o's timestamp matches the .c or whatever thing you're doing there. And anyone who doesn't talk file addresses and the atomic updates that come with them directly is basically wrong. This is why Gradle's morally wrong. They give you all kinds of fun task management, but then they screw up the timing systems with the OS, and then you get just incorrect builds out of a large parallel build system. Not mentioned hugely slow, but just incorrect. And you can't find the incorrectness because they're not talking the right things. So, make syntax sucks. I have all kinds of fun, tooling that knows make syntax and will let me write make files, but make files talk the right things. No bugs, super quick. I use make. It's stupid. I don't care. I would use another tool if it was out there and did the right things and talked the right way. Okay, so that's one part of that. The other part is I don't take any updates from the web by default, but anything, because I'm doing systems code, I need stability. And once I've nailed a version down, I don't want the update. If I want to take the update, I'll take it when I ask for it, never, ever again. That means I don't want to touch the internet when I'm doing a build to go ask if there's an update, because I don't want it. Which means, the failures that come out of a bunch of these build tools is that when I'm flying across the Atlantic on a 12-hour flight and I have a 1 byte per second, Wi-Fi connection, I can do email, but if I do a build and it touches the internet, it won't say no, it won't time out, it won't say your Wi-Fi's off. It'll say, yes, I can reach Maven at 1 byte per second. It'll just take me 10 minutes to verify that your version number hasn't changed. Like, holy fucking shit, dude, no. So, I have a step in my build process that says initialize and bring over the internet. And here you should have a good internet connection. Once that's done, I'll never touch the internet again unless I ask for another update. So I want don't touch the internet unless I ask for it specifically at my build step somewhere. And I have to ask for it explicitly, and I'll only ask for it when I know I got a good Wi-Fi. And turning on and off your Wi-Fi is like not sufficient, because that destroys things like being able to get your email and shit like that. So that's one of the things. The other one is I want the build tool to talk about file system artifacts directly. And then after that, I have a bunch of things that I do stylistically that I would prefer a build system, but I know these get more into what other people care left or right. And they're like successful build steps, report the file that they built. Depends on your verbosity level, but they don't spew anything else. The build system wants to would, coulda, shoulda, make does not do this. Validate that you don't have any extra artifacts produced, because they become state that you accidentally read in the next go round and become stale and out of date. So if you have a build step that produces a spewage of files, they should go into some temp directory. You should extract what you want. That should be marked by the make system as the file I'm looking for. And then the temp goes away on a successful build, and no spewage is ever allowed to accumulate state that you can accidentally read and get out of whack. So no count of times I've had people who had nice, good, fast running build systems that accidentally accumulated state, and whenever they did a make clean, they suddenly discovered they had failed to be able to build up all these other artifacts that they had built at some point in the past, lost the ability to build them, never rebuilt the artifact. Suddenly the new guy comes in, tries to build from scratch. He didn't have this artifact, he can't build it. No one can build it. We have to go roll back the fucking make system, sort out where and how you build this thing and get it tied. So make system should verify you have no extra artifacts.
Predictable builds.
Yeah, repeatable builds. And CI kind of does that. Like it should, but most CIs, in the name of efficiency, do some sort of incremental thing. And a from scratch build as a new employee who has no tooling except what they're going to pull in directly is a critical piece of a decent real CI, because otherwise you can't onboard a new person. And of course, if you ever have to do a clean build anyhow, suddenly you discover you have all your tools wrong. You also discover shit like Joe across the street's been running GCC version 2.3.4, and I've been running 2.3.5. He's running 2.3.7. He's running 3.2.1. Blah, da, 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 da. And the artifacts are not compatible, although you don't know it yet until you start crisscrossing things between each other. So there's a build, chain, rebuild from scratch thing that has to happen. Okay, I'm done ranting.
Okay. How about the build language? Should it be part of the language, or it should be external language?
I I do not like it when my build script is Turing complete, because that gives me an option to introduce an off by one error in the build in the build system. And I've ran into that, especially with Gradle, where where you have Groovy, which barely has a type system. And it's one of the things I hate XML, but Ant is one of the few build systems that I can actually use because it
hate XML.
I hate XML too, but it's just, I can actually grok what's happening. Like, unlike Gradle, where it's just like, oh, I call into this magic thing. Like the SBT build system, before it was called the Scala build tool, was known as the simple build tool. And that was the biggest lie that was ever sold.
Yeah, SBT is a huge failure story, because although it adopts most of the Maven policies and structures, it was a gut wrenching. They wasn't built a nice API or a stable API, if you will, and it was a gut wrenching all the way down.
And it's just, and I also just, I don't really want to have all these conditions. Like, I understand there's going to be conditionals, like if OS Windows target this, but it'd be nice to have sort of a DSL that's well documented. What's happening, unlike in CMake, where I have to fight the documentation to try and understand what's happening, and I still don't understand.
Right.
And it's just,
I'm talking make, not CMake, and a very minor subset of make. But
okay, I
I
talk about the build language. Should it be a different language like Gradle or CMake or something, or it should be embedded in the language you build your program with your compiler?
Right. So I have done it the way that you're talking, where I wrote a build system as a stylized Java program. And you did a lot of cut and paste to put in a template for another file, another file, and there were patterns to do this. And building hotspots kind of complicated because it's a compiler generator and a bunch of OS specific pieces, and you wanted to cross build 5 different versions, and you had to do tiered stage things, and you wanted incremental on a compiler generator, whatever. Fine, it was complicated. So it was useful if you followed the rules that were sort of buried in the boilerplate. It worked okay. You did have the Turing complete problem that you could work yourself into a corner. So you needed the discipline to not make your life too complicated because you accidentally did something super clever and later lived to regret it. I did that a couple times.
So you do not want your compiler at your disposal at the time of your build program.
It's not the compiler, obviously. It's the typing system.
The capabilities of the standard library and etc.
Yeah, right. And I'm just like, I'm going back and forth. It worked. It needed discipline of a different kind. Gradle needs a certain kind of discipline to have any hope of use, and I still claim it's a fail. Make forces you to have the discipline and also gives you a rather barfy syntax. It's a nasty syntax, but it forces you to have a discipline, and it misses out on a few features, like it's inconvenient to check for no side effects. It's not too hard to force all builds in a temp directory and wipe the temp out when you're done, which it's a discipline. And if you use it, then you won't have the stale artifact problem. I got that out of my Java code. On the other hand, like I said, Turing complete, like Anthony said here, it's Turing complete. You can box yourself in a hole every time.
Like, I'm not opposed to just like writing a plugin for your system, like Ant. You can write a task plugin to, let's say, do that. Like, that's fine. It's just, where the problem is if it's in that plugin. If that task fails, well, now I need to go debug that task. I would much rather do that than have to fight with the configuration of the entire.
But we slowly go into the build abstractions, the task, the workflow. Your build system has to kind of build some abstraction around it and a nicer API.
Because I would rather just be my build system, just be a task of execs. But it's my real statement is, I think build systems all have a certain level of suck that you all have to eat at some point. CMake is really complicated. Gradle is Gradle. Ant and Maven have XML, and Maven calls the internet every 5 minutes. It's just,
One of the major things that comes around is there's a scaling on the build system. As you do it for one person, you have one set of issues and you can sort them. You do it for a team of 50 people and you have a different set of issues. And the rat hole you really badly want to avoid is the one that says it's so complicated that no one wants to touch it. Because then you get an ossified build system and you leave a lot of really good forward progress on the table because no one's willing to touch the build system. Then you lose the key guy who wrote it and suddenly you can't maintain it, you can't do shit with it, and now you're stuck. And I claim that many build systems that get overly complicated go that path. And sort of what you want to do, and I hate to say it, but you want to have stupid simple build system setups. Really stupid simple. All the games where you do automatic Java versus Java C and .O from .C and .C++, a little bit of that's kind of okay, but pretty soon you get into a point where you can't track what file got compiled with what flags under what conditions, and you just don't know. And while cut and paste is big and bulky and annoying, and you think you have cut and paste bugs, the other side of that one is everyone can see what the hell it's doing. So I would love to have a build system that was kind of like something sort of one line per file. It was explicit for everything that, well, maybe a couple lines per file. It was explicit per every file. Not too many sharing. You want some maybe, but you don't want too much of that or you get confused. And the rules of what file depends on what have to be just obvious as fucking hell, so that you can track when the system gets big and key people walk out the door that did things in the build system. You know, I left H2O, when I look at it, the build there, besides taking like an hour and a half from a clean build to do stuff, it makes 200 different calls to R and PyDocs and Python this and that and other things. And it needs a huge count of tools that are not obvious where they come from and why. And an empty build where everything's all up to date takes like a minute. Whereas if I do a make of the core H2O libraries, because I'm doing a startup that's doing, you know, H2O based big math things, empty build takes a quarter second, right? I don't care. I hit the build button in Emacs, it's done before I lift my finger.
So it have to have the build to have to have a support to build multiple languages beside your own.
Yeah, so you can write in any Turing complete, so reasonably robust language. Let's say Turing complete, doesn't have to be Turing complete, it has to be reasonably robust system access. You know, Make's not Turing complete, but it has a really robust system access. Writing it in Go or Java would give you, you know, robust system access, but it also gives you a lot more rope to hang yourself.
If you have a language that you can distribute as a single binary, I give you the thing that I can use like a JIT and just be like the binary space, some code file and let it go.
Well, you can't send one binary to different OS.
Yes, it has to be one binary per platform.
Per platform, yeah, because the launch has to come up and run.
But if I can just drop the platform specific thing that is my JIT, and then I just have a script that is my build script written in the language, and it can go to the network if it needs to go get dependencies, or it can do the build. Like, to some extent with the build system, your problem is your problem, and you're going to have to write code to solve that problem. Why not just do it in the same language as the thing you're building?
That's a nice
And again,
argument.
some of the things it's going to have to do is call out. If it needs to build a PDF of documentation by calling out to some ghost script, like
you
write the code that does that. Your
that's
problem
done
is your
pretty
problem.
Yeah, that's pretty often in Go, where they just like, well, let's just build like a build.go, put that in build, and then it'll just exec everything you need. And you know, there's no real problem with that. You know,
I've been doing in Java when I do these Java-based builds. That's how they work.
You know, like it's, you know, but because when you say build system, I usually imagine something that's, you know, for multiple people to use, not just that. I was thinking more of an abstract for generic. But if it's like for your one program, you know, there's no problem with just designing it in whatever language you're working in and just like have it just run, and then you solve the problems as you go along, because you know you own that at that point. You know, it's
right. Yeah, that's
and you can even check your build toolchain into Git every so often when it changes, so you know you don't lose your build artifact, your builder.
One interesting build tool I've been looking at that I will probably never use because I don't work in a mono repo is God, there's like 4 of them now. They all use the same syntax and I can't read. Bazel,
Bazel, yeah.
pants, and there's
I've
another
not
one
heard
that
Bazel. Throw a link to Bazel.
Bazel is internal build tool for the Google. They're open source it as a Blaze. Google internal name is a Blaze in the Google repos, but the open source tool is Bazel.
yeah,
And it's basically a pants. The Twitter tool is basically a shallow copy of the build tool.
they all use this. They all use the same DSL, which I still cannot understand.
I got some reading on it.
You have a build, basically you have a build files everywhere. You have a build file per directory. You can instruct the build tool to build it. It's a long conversation, but basically the build files control everything. The toolchain, the build process, the target binaries, and etc. etc.
All right.
Do people have opinions of generating binaries versus outputting something more like a jar that needs a runtime?
Yeah, some folks just have to have a binary. There are times you must have a binary.
You know, it's like, well, I mean, if I'm trying to write the thing that runs the jar, I need to have a binary.
Right. You're on the OS or device drivers, you need a binary. One of my goals at AA is to be able to support people who are doing that kind of coding. And that being said, I'll probably still have a runtime JIT and GC optional. But if you're writing OS, you're not going to have a GC.
Yeah, like
a bunch of these things are in how you want to. What's the level of tooling that you want to have baked into the virtual machine you're building, basically.
I'm because I get because there's an application. What I wouldn't mind is actually if there's like an intermediate, like you compile it down to your jar, which then compiles down to your binary, which is something I'm thinking about.
Yeah.
Where you basically have 2 modes. You have your JIT mode, and then you have your native mode that comes from your bytecode, which I'm
kind of in the zone of I'll have a version that boils it all the way down to a binary and a version that stops somewhere and ships and it does the final drop down with a runtime JIT, because you get profiling information and the runtime JIT can profile and make life faster. That's part of it.
Yeah, I do sort of imagine it would be an interesting world where I could get one binary that's actually got 4 or 5 different interpreters in it, so that it'll run on any platform. And then it interprets the JIT, and then the JIT compiles itself, and now you have a native JIT, and then you start running all of the code.
Okay, so now I have a stupid war story from years ago. So we're writing this PostScript clone in a laser printer, pre-Apple laser printers days. And it's at EEPROM, so the 68,000, so there are 4 bytes wide to make a word, and you needed 4 EEPROMs, 1 byte per EEPROM, and you pulled the fresh ones out of the UV Baker lamp that erases them, and you burn 1, 2, 3, 4, and then you plug them in the board and you boot it. Well, periodically you'd switch them when you plug them in, and your bytes would be scrambled. Of course, it would just fail to boot, and you have to sort out which one was which, and you didn't even the right order, whatever. So we finally wrote the starting address you booted up at would be independent of what ordering the 4 bytes landed, would always jump to a piece of code that was compiled one of the 16 possible different ways the bytes could be landed to spit out an error message saying, you goofball, you got the following order of what you dumped the chips in at, and you needed to shuffle this way. And it saves so much time and energy because you just threw them in and you hit the button and you're like, oops, and it would tell you, and you just like sort them and press the button again, and you got it. But it ran, byte ordering scrambled one of 16 ways. It's all good.
So Cole, what's the specific question you have in mind to be answered to? Data integration with the
version control. Yeah, I'm kind of. There should be some help there. One of the major things that I want to get out of the build system is that once I've hit a certain point, I want to go ahead and run a pre-push test that is part of the build that everyone in the team, like as a single person, it's different. But in a team setting, I need other team members not to screw up. So I need to have a pre-push test that does a minimal state of validation, and then it will push. And if it fails, it'll tell you. And because there's a team and people are constantly pushing and pre-push takes time, you have to pull from the VC, do a build, assume there's no conflicts, go ahead and run the pre-push, assume there's no error, and you push. And you wanted that as a build step that was pull, auto merge, if no error, run the pre-push, if no error, push, right? And that one requires some integration with the build system.
Okay.
I was thinking specifically with like dependencies, right? We used to kind of have like source code and version control. We'd make a build, like stuff it in Maven, like an artifact. Everyone would then build based on artifact ID. But now it seems like a lot of languages just want to short circuit right to give me the Git SHA and I'll use that library. So it's like we've obviated artifacts
so I have
as a middleman.
I have the rule that says thou shalt not touch the internet on a typical build.
Right.
Normal build step, right? But I have my go get the artifacts step.
Sure.
And the go get the artifacts step has the artifacts mentioned in some specific way. Now I'm using Maven's whatever version control numbers, you know, I'm running JUnit.4.1.12 or whatever the hell. I have something. It could be a SHA, I don't care. I have a get it step, and now I have it, and now we build against it. But yeah, however you want to talk about getting your artifacts.
Yeah. So in modern times, you have to be able to directly reference a SHA Git in order to,
as opposed to
depend.
Semantic version.
Yeah, as opposed to because you directly pull it from source. Okay, the semantic version jars are more of like a final products that are runnable, and you depend on them. So you have a problem if you.
You're pulling them that fast, you're talking about sort of high volume, high throughput updates, right? In which case you have a funny situation where you're expecting to get somebody else's I want to say outside of your project external thing that you have a close relationship with because you are going back and forth. And you're using get SHAs to go back and forth, which I claim seems like a very manual process. It's not this. I'm looking for where your use case is.
Everything is. Go ahead, Anthony.
But our use case for that is, well, my use case is for when it's not quite out and I just want to test it. I just grab Rust is really good at that with cargo. You just put in the get URL, the SHA, and it just pulls down that exact build. And then you have that exact build.
So you have a local, I am personally updating my version to test it.
Yeah.
And then if I love it and I can convince the team, then now everyone picks it up. Yeah, that's
and then I've also done it as a bisect tool in the build system where I was like, there was a bug somewhere here. And then I start doing a manual bisect from their source tree into my tree. I was like, oh, well, there's a bug.
Oh, yeah. Okay, so fine. So what that comes around to is there's a reasonable use case says the make system can pull a specific version number sort of directly all the time.
Yeah. It's, you know, it's not something I would ever recommend for. Yeah.
You're willing to be on the internet during this process.
Yeah.
Because you're continuously downloading large binary things, which is fine.
Yeah. Yeah, no, it's not something. I would never do that on an airplane or from hotel Wi-Fi, where hotel Wi-Fi is always slow and painful.
Right. Yeah. Pre-COVID, I did a lot of traveling and talking, and so I was all the time on somebody's funny bad Wi-Fi, and I just hated touching the internet when I was just trying to do my normal everyday shit.
I remember.
Well, you could have the repository clone locally. This isn't necessarily a network thing. You're on a private island with no internet, but like you've got like 100 things cloned.
I understand. And my experience with those things was that fucking cache went to the internet, and I don't know why. And it's real. I didn't have a way to control from my build setup to tell the cache I'm pulling from, don't touch the internet. Don't update the cache, don't check this or that or per version. I needed a bulk flag, don't touch the internet. And that has implications, like your cache gets stale and you know it's going to get stale and you don't care. Leave it stale. Right.
That initial clone from Git years ago was just god awful. Like Git's fast after you do the clone.
Right.
Like before then, you have to spend 5 years waiting for all the objects to download.
Right. Right. And that, by the way, is not true of all repository systems, but it's true of Git, which is, I get it.
What was really funny
for different reasons, but that's one of the things that's not great about it.
But yeah, no, it's been.
So Matt points out a useful thing, which is dependency management is not the same as build setup.
But there's a core part of the build process. I cannot separate them because it's
right. I'm kind of thinking that the build wants to talk dependency management.
Yeah.
So I don't know how to keep them totally separate, because even the cases we're just talking here, hey, I want to do get bisect. I still have a big enough build setup that I'm using the build tool to do my bisect. Now, what's the right way to go tell the build tool, tell dependency guy, pull this one, pull this one, pull this one, pull this one.
But I would think of a build tool as a low-level execution of a build graph. So you already have some kind of dependencies that are fetched from the dependency manager, and build is just the final step. This is just a dump executor. Well, it may not be completely dump, but relatively dump, very, very fast, very, very low latency execution of the build graph, period. And never, ever connected to the internet.
So the build only works
like Ninja. Like Ninja. Ninja is the closest, the Chrome build system.
Yeah, Make doesn't go to the internet either, but Make calls every tool on the planet, and some of the tools go to the internet.
Yeah, I think Make is far too complicated. I would view Make the same way you viewed Gradle. It's just too complex.
Okay, I would claim Make is hugely simpler than Gradle and does not have the Turing completeness.
There are levels.
I'd agree with you about CMake.
Now, CMake is a different beast than Make. CMake and Make are not the same.
CMake is a product of history, I would say. I mean, it's a path-dependent thing. If you were inventing history from the scratch, you would not invent CMake. I think we can agree with that.
Yeah.
Okay, in build tools, the simplicity is key. You don't have to find the build tool.
That's one of the rules, or one of the guiding principles is simplicity, because it becomes complicated. Because it touches your OS, it touches somebody else's OS, it touches stateful things all over the place. It has to be simple and obvious about the state you're managing. You're saying when you're writing your programming language, you want final fields by default, you want to make them mutable, maybe here and there, whatever you're going to do, but you're managing state. The build system is managing state. As soon as you're managing state, you need to have clear and obvious when the state's modified, when it's updated. You know,
the Basel model was something like your build system, your build as a function. That was a Basel model.
I get it, and that's the style that I go for. The build system that when I write my own, have them screw around. That they want to behave as if they're functional with memoization. Memoization, so they're efficient and fast, but functional is how you think about it when you're doing the build. This depends on that, depends on that, depends on that, and no other things matter, and there's no history. And memoization go fast. That's the goal of you want a build system.
Yes.
I'm wondering if anybody else has ever even heard of Cake or used it.
Is that C#'s Ant version, if I remember right?
No. Well, I tried to Google for Cake, and all I found, most of what I found was the C# build system. But this is back from the late '80s. I posted a link to.
I loaded the link just now. I have not heard of Cake.
So I think that the document has most of the source for Cake. It's intended to improve on Make, which does some things repeatedly and just wastes a lot of time, rechecking dependencies. Cake comes with a whole bunch of built-in rules and
so you're saying source code to Cake is included in that document right there?
Well, yeah, there's a shell script. I think that it looks like a good chunk of it, if not all of it.
Yeah.
So some of the ideas in Cake were adopted in GNU Make, like the %.o depends on %.c, for example. Does your C compiler do that? That came from Cake. Managing dependencies, say via header files. In Cake, you would not have a .d file included somewhere. You would just express in the dependency rule, %.o depends on %.c, and in square brackets, if I remember correctly, you'd run some program that answers the set of header files that .c file includes.
Right.
And they become part of the dependency rule.
It becomes
Cake looks at all of this stuff, builds a plan, and then doesn't ever reevaluate any of the dependencies again. It knows exactly what it's going to do, and it does it, and that's it.
Does it quick to find something? Does it change in the dependency? It has to have a pretty quick resolution if it build it once and stay that way. It has to have a pretty fast way to detect that something is changing in the dependency.
No, Cake is a very different philosophy than Make. It assumes that you've got your source and you've expressed all the dependencies you need, and you've got some ultimate goal. And if the goal is newer than everything, all the ultimate sources, it doesn't even build the intermediate object files again. It just says, oh, you're up to date, you're good. You change one source file, then it builds the object files that are needed for that, and then the archives that are needed, and so on. But it doesn't build anything it doesn't need to, and it doesn't recheck any dependencies, right? So if you have 75 files that depend on some header file, it looks at the timestamp of that header file once as it's building its plan.
The hard part is really the generator, because you don't want to get to the complexity of auto tools or auto.
So you could imagine generating Cake files from CMake, if you like, but they're, in my experience, they're much simpler than Make files generally are, because you don't have any implicit dependency, like I say, on the implicit built-in rules.
You break out two different things here. Make files, as commonly seen, can be hideously complex, and that's, in my opinion, that's a problem with people's self-control. I use Make all the time. I claim they're stupidly simple and straightforward, and I know I can make them complicated, and I just don't. The other piece of that is when I've done the standalone tool I've written in Java or written in Perl, God only knows. I do exactly the kind of things you're talking about with Cake here. Automatically configure out dependencies of header files, which is a C thing that's specific more to C than necessarily other languages. Automatically, whatever, it does all the time. Checks just once. That's never the problem for terms of performance of the build tool itself. But it can be, I guess, it's an enormous system. You keep rechecking timestamps.
The philosophy of Cake is that it doesn't know anything about C or any other language. It just understands that you might dynamically need to express dependencies.
You have some dependencies that turn out to be C specific because they have to parse a .include list somewhere, and you have to have a way to get that. And so you have to tell the system there are some extra dependencies that aren't expressed in the Make itself, in the Make file itself, or the C Cake file itself. You're going to discover them. Here's how you discover them. You have to go ask the discoverer.
We see something like, okay, go ahead. Sorry.
So when you're writing a new language, your import statement needs to be able to find code wherever that code is. Do people have opinions on whether there should be some kind of dependencies file that explains where to find that code versus something more implicit where it asks you to lay out your file system in a particular way?
I like to lay out the file system.
Say you provide a tool that answers, what artifacts does this thing depend upon?
He asked an inverted question. I'm writing code. I'm writing Java code. At the start, I say package, blah, 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 import, blah, blah, blah. I'm writing C code. At the start, I say pound include, blah, blah, blah. I'm writing Python. I say import, blah, blah, blah. Okay, how does blah, blah, blah turn into a file that gets sucked in?
It doesn't have to be a file.
It turns into an artifact that gets pulled into my namespace.
We have to extend the import to import a resource. That can be a file, that can be a source code, that can be a binary, that can be a hash.
PNG sprite for my game, whatever the hell,
okay.
Right? Something. Okay, no, what I'm asking, or what I heard got asked to Aaron is, how do you convert, what is the translation step between the text in my source code and what file got touched? So one of the, what artifact got touched, right? So is there another entity in between, a dependency manager, or do I talk to the file system directly and therefore my file system demands a layout? And I have a strong opinion on that one, but I said it, so. Other people.
I would vote for dependency manager. That's my opinion. You have to have something in between to resolve your dependency.
Okay, I would strongly say no.
Okay, that's fine.
And I'll back it up if you want. And Keith, what are you trying to say then? You're talking about what Cake does.
Cake doesn't care what the answer to that question is.
Yeah, but he has to figure out where it says the cake's coming from the other direction. He's saying, given a source file, go figure out what the dependency is to something else. Okay, I'm writing a source file. I'm in my editor looking at the source file. I want to type something. What the hell am I going to get? How do I tell what I'm going to get? And that's the reason I don't like a dependency manager right there. Because I have another layer of indirection.
I'm not particularly see the dependency manager, but I want the program to tell it, here is that file. Give me that file on which file it depends to build me a dependency graph.
Okay, so this gets around to the cake problem of how do I get the dependencies from the source code? And there's a tool or widget or something that says, here's your dependencies. So if you land a C code, you can ask GCC for the dependency list. And he does a fake parse compile and collects the dependencies and tells you. It's great. In the land of Java,
I
the
agree.
import statements and the package statements are very well specified and you just get them easily. In the land of JavaScript, you have no fucking clue and you pray to the gods that you get them when you run some sort of NPM manager, but people pound include all kinds of shit from all over because they do evals under the hood and whatever, and you have no clue what they're gonna go get. And all these fancy technologies and words to try and guess, and they're all guessing.
But the Java is it has a head start because it mimics the directory structure in its package.
And C actually mostly does as well. There's two different ways you do a lookup, whether you're quoted this way or that way, but you're doing a file system lookup. Python kind of does that, except he has more games to it and he can go do other things. JavaScript is like, we don't have any official policy, so we have eval, and everyone who writes their own kind of modules uses eval in a different way. But we understand the following 3 different module systems in some of the tool chains. And so it's kind of sort of, hangs together sort of until you go outside that. And then people do all the time. It's like, oh, fuck.
I mean, there's a certain elegance to that, to say the way that code is loaded is you eval it. And you got a string to eval somehow. And then import is just a function that is written in the language, and it does what it does.
I am all for that concept, except I want to have a way that you can say, here is the de facto encouraged approach to specify dependencies. So when I go from a file to a large project of
right,
many
you give them
files,
de facto by including a import statement in the standard library.
yes, you have some sort of well understood syntax. Everyone gets it. And if you go outside that bounds, you don't land in the dependency system because you didn't use the import word. You did eval, and therefore you have to have arranged for your life dependencies some other way.
So how do you feel about like having multiple like keywords to do the same thing? Like, Java has like require, not Java, JavaScript is like require, import.
Currently I have 0 keywords in AA.
Yeah.
And so I'm all of the,
So you're against Anthony, you're against a specific overloading the meaning of the words?
Is the question
the concept specifically?
Like I have 3 different module systems and 3 different ways to import modules and describe them.
It's like,
this has nothing to do with keywords. If it's module systems, are you upset about keywords? You're upset about module systems.
I just want, like, if I'm programming one thing, I just like, if you pick one, you have to stick with one for that entire runtime, and you don't mix and match, because you can get shot in the foot in 40 different interesting ways.
What JavaScript program ever shoots itself in the foot?
Well, fair. That's a good point. That's a very good point. It's like one of my issues that I have with Scala 3 that just came out. Like, there's now 2 different syntaxes for the language for no discernible reason aside from they can do.
Where's the XKCD cartoon? There are 14 standards.
Yeah.
You need to unify them all.
And 15.
Okay. And now I'm waiting for the new Scala standard.
Okay, what does Scala 3 specifically disturbs you in the syntax?
It's not that I'm opposed to having a new syntax in Scala. It's the fact that there are now 2 different standards in the language for the syntax. If you're going to go all out with one, stick with one. Don't split out the things. So that way, when I read artifacts, I now have to go out of my current paradigm to, it's like, oh wait, okay, now I have to read this way. Like,
Okay,
and I
besides that, There are two ways to import it. They are de facto how the ABI, if you will, they're compiled to tasty. Then how Scala 3 and Scala 2 are compiled to one format, if you will, in order to be backwards and forwards compatible.
Yeah, but like
maybe backwards, not forwards.
Yeah, the issue is more of I have to sometimes go in and PR these things, and I have to sometimes reference my code, which is written in one way, and then I go to somebody else's code base, which is written in another way. And yes, programs can like have like, you know, you move the brackets wherever, something along those lines. But when you start going to a significant white space to a not significant white space, it's a completely big paradigm shift. Just pick one.
Okay, I agree with that, but is it that different to quote to another library that is written in different language? Because essentially we are not far away between Scala 2 and 3.
Like if it's easier for me to can you rephrase that? Were you saying is it like porting from different from a different language, or because I'm not sure what you meant by that?
By which it is I see it essentially if you wrote Scala 3 and Scala 2 is essentially the same if you wrote the other library that you use in different language and you treat it like a different language. Why is that you bother it that is two ways to do it or more ways to do one thing?
I'm not mad about two different ways to do it. It's two different fundamental syntaxes that I have problems with, and it's just it feels like overcomplicating the language to me at this point.
Because
like
you're complaining
the way
about
I see it,
overcomplicating Scala.
Okay. The way I see it, Scala 2 was all about the orthogonal concepts that they're really does not to do much with each other. You can use the concepts without using you can use the one without use the other, but Scala 3 is more about stitching the things together because they found some things that doesn't play nicely together. For example, implicit and overload, and etc. etc. And essentially, Scala 2 is about the more orthogonal concepts. You can use whatever you want, but Scala 3 is claiming to be some unified grand concept about what Scala is.
I'm just happy I have enums and I don't have to switch between to Java and Scala to use an enum.
Okay.
But yeah, it's just well, no, I don't know. It's interesting. Like I do not know why I am in love with Scala because I constantly complain about it, but I do love the language.
I do love the language. I learned to program in Scala, but it has made terrible decisions in some ways.
Yeah.
I would say, but it's a great language.
Yeah, no, it's really interesting because I've been playing around with Kotlin too. Kotlin's another interesting language. Actually, I enjoy Kotlin as much as I enjoy Scala.
I would claim that Kotlin stole most of the concepts from Scala, but okay.
Yeah, but the thing that Kotlin did right was, oh yeah, we're gonna just do Java compatibility just amazingly well, and Scala is like, fuck it. Also, I worked a lot with bytecode level stuff and bytecode tools. The Scala bytecode is not the most nice thing in the world.
Nope. Certainly not from usability from Java.
I tried hard to hook Scala into H2O. It's a big data machine learning all written pure Java, right?
Yeah.
And you want to write your inner loops in Scala and have H2 parallel distributed scale out. And the answer was, no matter how hard I tried in Scala, using every possible specialization, optimize me, please now, careful thing, it was always twice as slow as the equivalent Java code.
Yeah. Well, I mean, like before Graal had what's Graal's native image? Graal native image, whatever it is that compiles Java.
Native image,
yeah, C binary. I was using Scala native. Scala native was just amazing for that. Like that I was like, screw it. I'll just use that.
Yeah.
It's a great tool for that.
Okay, let me ask you a question. What are your sentiments about compiling the Scala native 10 minutes in a production in a full optimized version? You literally compile 10 minutes to get 2 megabytes.
A different one.
That allows. I like
build cycle.
I'm happy with that because that means I get to have a little snack while I'm waiting for the test to pass. And I, that's
Okay,
like,
wait,
that's.
Are we talking standard build while I'm doing edit, compile, debug cycles? Or are we talking pre-push tests? Are we talking
the
you
whole,
know, CI
well,
tests?
The Scala native has a few settings to compile it. You have a fast build. It applies most of the optimization you can apply, and you build it and you get a 10 seconds build time. But it has a full build, which applies all the optimizations, virtual partial escape analysis, devirtualization, yada yada yada. But it compiles in 10 minutes.
Yeah, but that combined with the QA is like, I can just go out, have lunch, sometimes it's nice to have a break.
Was that a productive use? I get it, but just be implicit. I mean, it's when you need a break.
Yeah, it's it's slow.
In a XKCD, you have to buy a pair of swords and a body, so you can.
Right. Yeah, I mean, I've been there, and the answer is, the build times matter for productivity.
Yeah.
If you need a break, by the way, you should take your break.
Yeah.
But if you want to get shit done and the build system's taking 10 minutes a pop, you're
well, the answer to that is I don't really do full on builds like, because I don't.
Minutes a pop, of course not.
Yeah, no, I do the.
I have a few things built in Scala native. It's a pretty impressive project, so I no intended to bash it.
No, it's like, because you don't need to have the full production build immediately. Like, you do that, use the 10-minute build, make sure you have what you need done. Then you build the production build once to validate. If there's a bug there, then you cry a bit, and then you go back and start doing the debug stuff. But I mean, the longest time is never, for me, hasn't been compile. It's always been, oh, do the unit tests pass? Well, okay. Well,
how
entirely.
That was the question I asked. Yeah. How long is an acceptable delay for unit tests to pass pre-push?
God, it's
1 hour, 1 minute, 1 hour, 1 day.
It depends on the unit test and how important it is to, not brick the user system. So that's a sliding
30
scale.
minutes.
Okay.
But it also depends on how competent your test writers are, because people don't understand test-driven development anymore. It's like, oh, we need to test the implementation. No, test the exit points. Like, make sure those don't fail, and so that way you can change out the implementation willy-nilly. Don't do a test on the inside.
Let's not ran on test-driven test writers here.
Yeah.
I want to go down the 30 minutes versus.
Here's something interesting I built with Scala native.
Max
it's a cool library.
So I've been in zones where I've hard capped it at 5 minutes.
Yeah.
I've been in zones where it was 3 hours.
Yeah.
Done hotspot doing a new JVM build. The CI turnaround for the test was 3 hours. Of course, there were 70 people working on the code base. And so you had to have a lot of stability, but it meant that you had a dozen pushes, that 20, 30, 40, 50 pushes in a day. You didn't have that many hours in a day, so they were all running overlapped.
Yeah.
People would integrate to top of tree, run their 3 hours of the test. There'd be a dozen more pushes pending behind them, and they pipelined them real deep. And it was an amazing thing. And I was part of getting that process going. It was a big pile, but 3 hours for a hotspot, which I think makes sense. I understand 30 minutes in some contexts, 5 and up.
It honestly depends per code base and what's your stability, what do you want, I like an hour is acceptable to me, depending on what we're like, on how important it is. Like, if we're working on something that,
well, more testing actually provides more stability.
Yeah. It's
like, if I'm doing like big data machine learning, the tests seem to be big, but they don't provide more stability over sort of a well-chosen set of more modest things. Yeah. Whereas hotspot has a giant parallel distributed or concurrent algorithm, has long latency, a long bug tail, low frequency, long bug tail bugs, for which time actually provides a higher rate of catching them.
And then like in some of the stuff I worked on, like we have to build on 40 different machines, like RISC, X86, ARM, some shitty Pi that, whatever.
Yeah, all right. We're having a great time, but like people are bailing out here. I'm gonna wrap up here.
We're still two. We're Still 10 people, 9 people. I don't know.
It's like, go, go,
11.
go. No lunch
11.
for you.
Okay. Yeah. No.
I'm watching Charlie's baby too. He's asleep.
Yeah.
You're being a good dad. You know, go to hold this one. Where's the other one? Is he asleep too? Mom got him.
No, the other one's fussing downstairs. When there's two fussing, someone has to take the second one. Not nice to leave one person with two.
Yes, well, it happens. You get more kids than adults. You go from one-on-one to zone defense.
I'm very happy it wasn't triplets.
So how many? Is this your first kids?
Yeah.
Well, congratulations again.
Thanks.
Yeah. We went from 1, 2, 3. The level of worry changed in your level. I would say level of care is not the right word. Intentional inspection or something. First kid. I didn't do twins, by the way, so I can't speak to that. But first kid, you drop the binky on the floor and you boil it 10 minutes to sterilize it. The second kid, you pick it up and you rinse it off and you stuck it in. The third kid, you tell the first kid who's now 3 or 5, go put the binky in the baby's mouth, right? If I can get 4, you're like, the dog puts the binky in the kid's mouth. You're just like, don't care.
It's the great thing about having people, having kids that actually listen to you. I remember when I was,
I just said it's all about getting your immune system on your kids, robust.
I remember when I was still going to college and I stayed home and my mom was like, you turned 21 today, right? Like, yeah, no, just go buy me a beer. What's the point of you being here going to college, not paying rent if you're not willing to, go get me something to drink. Oh, and that was my rent. Go to get her beer.
There you go. That sounds good.
That seems like a pretty good deal for rent.
Oh, it was an amazing deal.
Yes.
Going to that community college for $2,000 for the entire thing. Oh, that was even better.
So I'm curious, Alan, you said your language was mostly based on model checking. What's the sort of thesis statement of that language?
Oh, well, I mean, I said that to introduce it, but I mean, like there's a lot of things going on in my language. So like I actually have a build system design, for example. It's based on like incremental multi-threaded computations. So like, I mean, the threads record what they read and what they write, and then you can replay them. And then I have like, there's macros in it, and there's what else is there? Oh, there's predicate dispatch. So there's like a lot of, I don't know. The model checking is, I think, I brought it up because it's kind of the compiler aspect of it. It's how I implement, kind of the back end sort of stuff with like checking. Yeah.
Model checking for type checking.
Yeah. So like instead of type checking, I have model checking. And instead of compiling, I have partial evaluation. And so, and that's, yeah. So that's kind of the idea. And it's kind of coming together. Like I'm reading more papers. I mean, I'm working mostly on the front end because that's more fun. But like the back end, it does, like I do have some ideas on how to implement it. So.
Okay. Well, have you got a link to any sort of documentation?
Oh yeah. Let me throw a link in. So like it's the documentation is like a work in progress, but on the other hand, it's the only thing I'm writing. So I'm not writing the code yet because the documentation changes. But yeah, so
sometimes that's nice, to have to know what you're doing before you actually start doing the code. I was like,
a mission statement.
Yeah.
It's the waterfall model of development, which kind of went out of favor in the 70s for good reasons.
Yeah, but
it's nice.
Yeah, because it's great because I decided to introduce macros into my language. Like, well, now I have to write a parser in my parser because it's different syntax. I'm like,
But it's the whole issue of macros. Are they hygienic or not? Do you get name structure mistake on purpose? Whatever.
Well, because I'm trying to figure out, because I was like, well, do I want a GC or do I not want a GC language? And it's a very fundamental thing. I'm like, well, why don't I do a macro that implements new? And then I can just choose a compile time or any of that stuff. And like, I'll still give you access to free and stuff, but I'll just wrap malloc and whatever.
And Matt's got a good point. Absolutely. The problem, of course, is that
Yes.
my plans all end with, and here I don't know what to do. So I have to go code for a while, and then I get there, and then I, well, this will be cool. And then a little while later,
Yeah.
oh, that didn't work, but that'll be cool. And this and that'll be cool. Oh, and then you finally
Like-
figure out what the real problem was.
It's what my
That's
friend
basically what Scala language was. There's a bunch of students coming in and implementing feature after feature after feature.
That's what my friend likes to call the improv model of programming. You just keep on saying, oh, and yes, oh, cool, yes, and yes, and yes.
Yeah.
And then it's just have to go to a point. It's like, okay, I need to stop.
I do, you know, I have a philosophy there. Some of that is correct. You don't know where you're going and why, but you have a goal in the distance. You're trying to get there, and you can't cut a straight path through the code jungle because you don't know what the path is. But when you got to the El Dorado you're trying to get to, you turn and look behind you, you can see the zigs and the zags. Now you can cut a clean path through and make it tidy and neat. But you couldn't get to El Dorado with the straight path because you didn't know the route through the jungle.
It's like, I know what I want. But there's a difference too. Like, you can know what you want like that, but you don't know the path. Like you said, you don't know the path. So write down what you need. And then what you do is like, okay, well, how am I going to get there, and document your way there. So that way you don't forget halfway through the implementation when you're committing at 3 a.m.
Oh, yeah. Well, I do some of that. I forget, and then I come back later.
I would like to take the chance to congratulate our faithful chronicle, whoever he is. Yeah, man, you're killing it in the Google Docs.
Oh,
everything is documented.
Oh, look at that. All right. Thank you.
Oh, yeah, that's me, by the way. I was the one who the timestamps.
Cool. You're killing it. Yeah. Thank you.
All right. Now I'm going to pull the trigger for real.
Okay.
It's been very entertaining, very good.
Cool.
And hope to see people next week.
All right.
Yeah.
All
Okay.
right, bye.
Bye.
Get some sleep, Charlie.